The ocean floor represents a realm where existence tests its ultimate boundaries. Throughout this series, we've witnessed how creatures adapt to frigid temperatures, perpetual darkness, and crushing depths. Now, it is time to descend even further, because beneath the Pacific lies a concealed chasm unlike anywhere else on our planet. Here dwell creatures appearing faceless. Vast bacterial clouds blanket the seafloor, and colossal beings seem transplanted from alien worlds. Let's venture into the mysterious realm of the Mariana Trench. The legendary Mariana Trench stretches across the Pacific floor like a crescent-shaped wound, extending 2,550 kilometers in length and 69 kilometers in width. A fracture plunging into absolute blackness. At its base lies Earth's deepest known point, the Challenger Deep, resting 11,033 meters, or 36,200 feet below the ocean's surface. This chasm belongs to a worldwide network of deep scars carved across the seafloor. These features emerged through subduction, when the Pacific Plate's western boundary was forced beneath the smaller Mariana Plate. Subsequently, volcanic activity near the fracture created the neighboring Mariana Islands. At its most profound point, the Mariana Trench penetrates a zone called Hadayal, named after Greek mythology's Hades, a fitting designation for a realm where complete darkness, acidic frigid waters, limited sustenance, and tremendous pressure combine to create extraordinary survival challenges. Throughout most of recorded history, people considered this a lifeless wasteland, devoid of any organisms, an unreachable boundary and perilous void no human could ever access. However, the 19th century brought transformative change. The Mariana's depths were initially measured in 1875, when HMS Challenger's crew lowered a weighted rope and discovered they required additional line. They hadn't anticipated such profound depths. News of this discovery spread, inspiring bold individuals to attempt reaching the bottom. In 1960, 85 years following the Challenger Deep's discovery, two individuals embarked on a journey to reach the bottom. Jacques Piccard and Navy Lieutenant Don Walsh, protected only by a confined bathyscaphe submersible named Trieste. Their 5-hour descent presented numerous obstacles. Water pressure near the bottom exceeded atmospheric pressure at sea level by nearly 1,000 times. During their journey, this pressure fractured the viewing portal, restricting their seafloor time to merely 20 minutes. Yet, even in such brief moments, their observations would astound the scientific world. Life existed. Pale shrimp and flounder, resembling fish, alongside a brown substance coating the ocean floor. Piccard enthusiastically documented this moment in his expedition account. Here instantaneously emerged the answer biologists had sought for decades. Can life thrive in the ocean's greatest depths? It can. When James Cameron followed Trieste's path aboard the Deep-Sea Challenger in 2012, he also observed sprawling microbial mats, peculiar thread, like bacterial clusters, subsisting on chemicals from modified rocks, 10,912 meters down in a sunless environment. These bacteria sustain more complex creatures. Without solar radiation, larger organisms must depend on bacteria performing chemosynthesis, the deep ocean's equivalent to photosynthesis. The footage you are witnessing was captured by a Japanese unmanned submersible called Kaiko, reaching 10,897 meters depth. It represented the deepest unmanned submersible dive at that time. Its objective involved collecting bacterial samples from the mats Piccard and Walsh had observed nearly 4 decades earlier. They discovered several bacterial species appeared to be obligately barophilic, meaning they flourished under elevated environmental pressures. This demonstrated our misconception that life could only exist under moderate conditions. But in 1998, Kaiko returned to Challenger Deep and encountered more sophisticated life. Hirundella gigas, a massive amphipod species. This revelation presented a puzzle. The deep ocean's tremendous pressure causes calcium carbonate, which forms amphipod shells and many marine creature exoskeletons, to dissolve more easily in water. Consequently, amphipods typically aren't found below approximately 5,000 meters. Yet here in Kaiko's illumination appeared a giant amphipod, maintaining its robust exoskeleton. Subsequently, scientists learned they safeguard their shells using aluminum armor, employing chemicals in their digestive system to extract aluminum ions from seafloor sediment while foraging. As detritivores, these amphipods fulfill a crucial ecosystem role. They function as cleanup crews, possessing enzymes capable of digesting even wooden material. Recently, remote submersibles have illuminated additional Mariana Trench oddities. Among the most plentiful residents are holothurians, sea cucumbers. Like the extraordinary sea pig with its ring of feeding tentacles used for sifting sediment and grasping sustenance. Some scientists theorize Picard's fish was actually a sea cucumber. It is believed fish cannot survive where pressure becomes so extreme it would dissolve vertebrate bones. The deepest confirmed fish flourishes at 8,000-meter depths. Still 2 kilometers above Challenger Deep, the Mariana snailfish, discovered in 2014, received the scientific designation Pseudoleparus swirae, commemorating HMS Challenger's sub-lieutenant Herbert Swire. But snailfish and amphipods aren't the sole curiosities. Enormous xenophores expand to 20-centimeter diameters, yet comprise only a single cell. Predatory tunicates called sea squirts attach their bodies to canyon walls awaiting passing prey. Deep-sea hatchetfish employ bioluminescence to blend with surroundings. Though only glimpses of these otherworldly organisms have been documented, their abundance demonstrates that life invariably discovers survival methods, even confronting the intense challenges of dwelling in the ocean's deepest realm.